Also, as we get into the group project, I want you to commit to your group as well, because how well the group does is not just an individual working on it, but the entire group. Okay, let's see. Okay, the application we were working on, and I'd asked you to use breakpoints to figure out whether the logic was working or not. Did our test, when we ran the test, did it run or not? It didn't run. Okay, so we put these breakpoints, right? And what did I ask you to do?
Let's run through the breakpoints and see where the problem was, so we can figure out what's wrong and why it wasn't working.
Okay, so how many of you figured out what was wrong? And so with anything, and this is not just for this, and this is a relatively simple program, so it's not just for coding, but in anything you want to do. Whatever you're designing or trying to figure out, and let's say it's not working, what do you first need to do? You're trying to fix it? What's the first thing that you need to do in any systems approach?
You have to find out what's wrong.
Exactly. Try to first understand the problem. Why is it so important to understand the problem?
So you fix the right thing.
Okay, when you say fix the right thing, can you fix the wrong thing?
You could start messing with something that you mess with, waste your time and possibly mess up more.
Yeah, if you can have the illusion that it's working, right? The thing is, I could go back, for example, here and say, well, when I run this test, it says the test failed. The expected was 0, actual was 1. So I could say, well, expected was 0, actual was 1. So to fix it, one way to fix it would be, well, I'll keep it on here, to just say, well, I've changed the expected, and then what happens? It runs. So I can be perfectly happy with this, right? So why can't I be happy with this?
You can't get happy with it because you just changing the numbers so it works, but it's not actually giving you, it's not actually the right result that you should be looking for.
Okay, so I fixed the problem, but I didn't, well, I had the illusion of having fixed the problem. So the issue is not so much as getting the test to just get the green check mark. That's not the objective. The objective is to get it to check it correctly. So if we don't, then there's no value at all in these tests. So that's why I said it is important to first understand what is the problem, and then to understand why it is a problem, and then you fix the problem. So the issue is, as Taylor said, there are you can supposedly fix it where it actually causes more problems, because ultimately it's going to show up in the user's experience, and the user's experience is bad. Nobody is going to use it. Essentially, if this is a company environment, you're potentially either incurring losses, or basically, if it's an entirely technology company, putting them out of business. So so it's important to find out what's causing the problem. So in this case, what is causing the problem? That's where the breakpoints help you. So I'm going to come around to see what you have done to try to fix it. So I'll just go around and see, show me what you did. Okay, so you have to think, because if you just see me doing stuff, okay, and I keep bringing this up in every class, if you see me providing whatever the program or the so-called solution, who's understanding it? Mine. It is mine. You have not shown that you understood anything. You just shown an ability. All you can put on your resume is, I know to type. That's all they're doing, right? It might sound harsh, but that's the reality. If you want to understand, and this is a word that many of us don't like, struggle. Struggle, is it a good word? In the context of studying or learning, this is a good word. Struggle is not a good word. It's actually good. If you're going to, with learning, if there's no struggle, it means that there are basically two things. If you don't struggle with something, what does it mean? It's so simple that you shouldn't be sitting in class to be learning that, right? If you don't have a struggle. The second is you already know this stuff. In this case, you also shouldn't be sitting in class, right? So if there is any value to something that you're doing, there should be a gap. And whether you call it struggle, effort, whatever else, there has to be some reason. Otherwise, you don't want to do it. There's no meaning in doing it, right? So that's where there is a need to read, whether you say effort, struggle, or whatever else. So that's, and I'm deliberately pushing you there. And it's not that I want to make you suffer, right? That's not my objective. I want you to be happy, but and I have the part of what we do is problem solving. So I want you to enjoy the process of problem. If you don't enjoy that, it's not going to be. But anyways, I want, even if you don't make it, I want to see the effort. Yes. Okay. So let's see what we.
You say correctly, so I'm trying to redo the.
You do understand. Do you have a thumb drive?
Yeah.
Okay.
I don't
Let's see. What did you do?
And I just use it as a kind of, I can't, this is from some version.
Well, what are you using? What's the microphone?
No, it's like that.
Okay. Okay, so it should be fine. If you're just saying the
No, just like
oh, you mean the test? All right. What did you read to say? Well, when you change the input, well, we need to check it for different values. The very simplest is failing. So obviously, the later one, so if it doesn't work with the simplest option, then we don't want to push it to a higher value. Right? So as soon as something fails, we need to figure out why and then try to fix it. So do you have? Okay. Starting with 1, 0, so for 0, you get 0. Some other value. Well, what you want to do, is at least the other drawing. So you want to have it as a second test. So not just, okay, let's see. Well, you might have some different logic. Did you have this in your program? Did you have this logic? You might have had it changed. That's runs now. Okay. Did you have another value? Because if you go back to your test, if you try with any other value.
So I read the entire thing on this, and so I didn't get what the breakpoint like what you but I was thinking.
Okay, so does the test run? What's this thing?
It's in.
What is it? If we give you like finances, I'll give you 300. Well, it's telling you right there, expected 0, actual is.
Actual 0, actual 1, so.
The way you read the errors is very simple. Just go into the Test Explorer, and if it doesn't show up, go to Test Windows, Test Explorer. It should show you here. And if I were to run this now, it should fail. And if I want to read the details, if I click on the test that failed, I'll get a message here saying what was expected and what the actual value was. Okay, so it's fairly straightforward. I'll just come around to the remaining slide of the test. This is what I wanted you to have.
I'm not sure I can read this.
You could have the expected 13 and pass the 4 or 5 pass. Okay, so let's go to our I didn't really change anything logic and expected result. The reason I wasn't working before was the first index would come back with a 0 for our expected value. Okay, so if you use the okay, so what did we have there? 0. So if you have that would have to return to 0. I guess the first 0 plus 1. So that's what I was thinking when I changed it, and then when I input the other results for indexes, it worked. Okay. So you change it from so if you use the So TJ, if you use the input term as 1, what is the result that you're getting? The expected number is what? 31. Is the expected number 1 for the first term? The first term. Yes, change the go into your test. It's in the test.
So that means that you already know that jumped it to 13, so the 8, that's why I don't use here.
Okay, so this doesn't work with the first term, so
I guess you can go back to
so if you have term number, so if it's using, if it's done 1, so the first two kinds are taking care of outside. The next one is less than, so if it is the second term, you don't want it to come in. So the third term, then you start getting the difference. Okay, so the issue is there are a few of you. Let's see who had this. Ashley, okay, Krista, you're Chris, right?
Yeah.
Okay, so Chris and Megan. Okay, and then Hallie. Okay, those of you who have it working, we'll discuss why it is not working, what changes you need to make. But and I saw a couple of you had said, okay, if I want to test it for a second term, I'm going to like if you look up, and I think this was Chris who had looked up the Fibonacci sequence, but we also discussed this. So if you look up, let's say the 6th term, or it should be 5. So so now we should. So some of you had done this. I tried to do this. But instead, what we want to do is to make sure that the first test is working as expected. So we will leave that as is. And then what we are going to do is change the value for the input term over here. Right? It's a variable, right? So we can change it sometime later. Now, if we change the input term to 6, what happens to the expected number? What are we expecting here? Okay, it's going to be 5. And so now that we have changed the input term, changed the expected number, what do we need to do here? Where is all the work of calculating the number done? Is it done over here? Where is it being done? Balaji, where is it done? Where is the work of calculating the Fibonacci number done? On the calculator, you don't say it's calculated page. You're now talking in object-oriented terms. So it's a calculated clause, and in the calculated clause, what does the work? What does the work inside of the clause? The method. Okay, so this is the method. So we want to call the method to do the work. So how do we do that? Okay, somebody, let me see, Kosh, how do you call that to do its work?
How do you call it?
Well, Balaji just told us the work is not done here, right? The calculation work is not being done inside of this test class. What's that? No, it's not done in the test class. The work is not done in the test class. If you don't understand this, that's a very, very fundamental concept. The test class doesn't do the work. What does the work? Well, it's in the calculator. This test is only for the entire. What is object orientation? What is the basic concept of philosophy of object orientation? You ever? Modularity. What does that result in when you have modules?
Breaking it down into a bunch of different components that each do their own piece of the work.
Okay, what Eric just pointed out, the entire idea of object orientation is just like everyday life, right? If you want to get, let's say you're applying to a university and they want you to send them some documents. It's in California. What would, let me ask somebody else, what would you do?
I would have to get all my documents together and put them together to California.
Okay, will you go, what is the first option you'll think of? Will you think of going physically to California?
Yeah, if they require that kind of thing. But if they require like just on the paper saying I went to school and I'm a good student, letter of recommendation, whatever, then I would send all of them together.
How would you send that?
And then they
Yeah, exactly. So you're not thinking of physically going there. You're using some other entity or some other service that does it for you if you are not physically required in that university in California. So you might think of the Postal Service or FedEx or UPS, whichever company that does it for you. So there is an entity whose entire purpose is to ship whatever documents and others from one place to another. You as another entity, a student, you don't do that as your service. You do something else. So the entire concept of object orientation is you use other services, and there's an interaction between these different entities, right? So each one. So if you said that this test does not only the testing but also does all the work behind it, then this one class and one method will become not just 10 or 15 lines, but how many lines will it have? Potentially hundreds of lines. So the entire concept was to break it up into smaller modules or different modules, each of which, as Eric pointed out, does its own work. And then you sort of call upon it. And what's the other? So the issue is now you don't have everything in one place. What's the other major benefit of creating these modules? Kash, what do you think is the benefit of doing it? We just said that we create multiple modules, each one of which does its, whatever carries out its responsibility or its service. What do you mean combine that? I don't want to just, when you, what does combine them mean? No, it's not. Can somebody else help us, please? What is the benefit that, other than Eric, Liv, Megan. Okay. So the issue is by having these all separated, so the Fibonacci number in this case, let's say we are just wanting to know a number, but we said in Scrum we use it for what purposes? We use Fibonacci numbers for what purpose? Importance, what else? Difficulty. So these two different purposes, right? So if we thought that we needed to generate the Fibonacci number each time, write the entire code. So let's say 3 different purposes, right? So if we needed to write this code, we'll be writing it 3 different times, the same code, right? So, but if you think in object-oriented terms, how many times should you write this code or logic? Just once. So so how many times are you using it? 3 times. So the concept of object orientation, one of the fundamental principles is what, Scott?
Yes, to categorize.
What did I just say? I wrote once, and how many times did I use it? 3 times. So what is it? It's called? What is it? Yeah, Bolaji? Reuse. I'm reusing the same code or logic multiple times, right? So I don't have to keep writing the same code 100 different times. In this example, it was 3 different times, but in a larger application, you'll call the same thing maybe 100 times. So you don't want to write it 100 times. And what is the other benefit with not having, you're using it 3 times, but you write it just once? What's the associated benefit? Not only reuse, but what else does it add? Efficiency, and something even more important than efficiency. What's that? Okay, in what way?
I mean, you're saving time by only writing it once, but you can be doing other things with that time that you only read it once.
Okay, but even more important, okay, it's easier to read, and let's say for some reason you need to change it. So right now this is giving us just one Fibonacci number. So let's say we want multiple of them. So how many places do I need to change the code? Yeah.
Just one, so it isn't redundant because
Exactly, redundancy. If you have it in multiple places and you find that you either made an error or have to change it, then you have to find those 3 or 100 different places where you wrote the code and make changes. Here you have to change it just once. So these are some very, very fundamental principles, concepts of object orientation, and you have to practice it. So if you have the logic, you put it once and then keep reusing it. But you need to test it with multiple, well, in this case, multiple different values. And let me ask somebody, and I guess that second row, TJ, how do I now get the actual value? Do I just, can I just go ahead and make this assertion here, just as I did? Input term is now different, right? 6 expected was 5. Will this work?
I think that one would work.
Okay.
The first one would work.
What's that?
To have like an if clause or an if statement.
Where would I have this statement?
In the calculator class, I guess.
Okay.
If the index is 1,
Okay.
equals 0.
Okay, so the issue was, let me just go ahead and run this. Okay, so right now the first assertion is failing, and what TJ is saying is, well, when there were several Haley's solution was like what's the underlying, so before we look at a solution, what is the underlying cause of this problem? What's causing this error? Why is the first term we are expecting a result of 0? We seem to have Fibonacci number 1 as 0. So why is it giving us a result of 1 instead of 0? Like even here, we initialized it to 0. Yes, TJ?
I guess when the for loop begins on the first term, it's already giving you back a result of 1, because you're adding Fibonacci number 1 and Fibonacci number 2.
Yeah, so one thing you can do, and that's why I said use the breakpoints and the debug. So if you debug something that is not that is not giving you the expected value, go into, so I took off the breakpoint here, so I set that up. How many of you use the breakpoint and worked on it? Okay. You didn't use it?
I kind of sort of, I don't understand it.
What's it? You don't understand the breakpoint, how it works?
I tried to use it, but I ended up figuring it out my own.
Okay. As the programs get larger, it gets more and more useful to use it. So it's a tool. So I personally found it very, very useful. So you know how to put the breakpoint, right? The gray column here. And usually what I do is I try to put the breakpoints, like if you saw it didn't stop here, it went directly into this method. And why did it do that? If I had put the breakpoint here, it would mean it starts obviously with this test. Right? But since I didn't put the breakpoint, the first breakpoint was inside the calculator clause, it went directly in there. So my first breakpoint, I wanted it in my test method, where before, this is the point at which I'm calling this method, which exists in a different class. And it also shows you how object-oriented programs sort of go back and forth between, so you can think of this as the student asking FedEx to do something. So these are two different entities calling on each other to do their work. Okay, so if I right-click on this and run debug selected test, it comes to the first breakpoint, which is in the test method. And what do you see over here? You can either see the window below, or you can hover over, like when I hover over input term, it gives me the current value in input term, right? And if I go to actual Fibonacci number value, it's showing 0. Where is the value coming from? It's obviously not as yet done its work and returned the value here at this point. So if I were to click on continue, where do you expect to go? Do I go to the next line? So if I had, let's say, another breakpoint here, would I expect to come to this? Where would I expect to go?
Get to the for loop.
Well, I go into this method here, which is inside of calculator clause. Right? So if I just click on continue, it doesn't come to this statement, but goes into this method, and there I've set my next breakpoint. And what does it tell me about the parameter value? Where did it get this input term from? The value comes from where? Okay, the test, when I called it, I passed it the value 1, right? So I'm here. And what's the next thing it's doing? It's coming to the loop here. And what's the index value in the loop? It's not yet run this. So if I run this, will it get into the loop here? The input term is 1. The index starts with 1. And as long as the index is less than or equal to the input term, it's going to get into the loop, right? So what's happened here? It's come into the loop, and Fibonacci result is the sum of these two, right? So, and then if I continue on, it comes and says, well, at this point, the index value had, once it became 2, it's no longer less than the input term, but the Fibonacci result is 1 as a result of having added up 0 and 1. And obviously, we wanted the value 0, so if we continue on, we come back and this is going to cause an error. Right? So if I run this, it generates an error because the values are different. So, Krista, do you understand how the breakpoints work? Okay. Yeah. So the issue is, so what is the underlying cause of this problem here? It will actually correct at this point, but when did it become incorrect? Where does the logic fail? Tell me if you understand where the logic fails. Let me ask somebody. Do you understand that?
Yes, I do.
Okay.
I do.
Okay, Bolaji, no? So it was fine before we came into the loop, right? But once we came into the loop, the value changed because it adds up 0 and 1, right? So one of the simplest solutions would be to do what? What did you do, Yamini?
I changed the index to 2.
And what does that accomplish?
Since you started with 1, or you already have 1 in the thing, you have to go up the number.
It's very simple. This is why I'm asking you to explain. What are you trying to accomplish?
You're starting at 2 because you're already giving a number. So
No, I want you to put it in very simple terms. What are you trying to accomplish when you say you're changing the index starting value? Krista, what did you try to accomplish? Well, you did the same thing as Megan did. You changed this from 1 to 2, right? Somebody else did that too. Who was that? Hallie, what are you accomplishing? Okay, so if we are starting with the first term of 1, we know that this result is correct as long as it doesn't come into the loop, right? So our entire objective is with this value, with the first value, we don't want it to even get into the loop, right? So the purpose of changing this to 2, the very simplest reason for doing that would be to prevent the first term from even getting into the loop. So that's the simplest explanation for this. So for the first term to work and give us the correct result, all that we really need to do is prevent it from getting into the loop. And if we did that, and the simplest way to do it, Hallie had used a little more. He had used if statements, which you can bring in, but even this which is a simpler option. You do the most minimal change, and that's one of the principles I want you to work on, is to make the smallest possible change. Coming back to your principle, right? Why do you want to make the smallest possible change to see if it's correct?
To not mess with anything that doesn't be messed with.
Exactly. If you make more than one change, one of my principles is I try to make only one change at a time. So I know that if something works, I know why it worked. And if something doesn't work, I still know that this one change didn't help it. But if I make 3 changes at the same time and suddenly it works, I won't know which of those 3 made it work. So anyways, let's go back to, okay, keep this breakpoint, and I will go back to my test explorer. Actually, I'll just run it this time. You can see that I didn't go into debug mode, so it won't stop. So I'm just going to run it and see if it succeeds or not. Okay, so this time what did it say? It actually, yeah. Is it 8? Let's see, what is my first term is 0, second term is 1, these are the 2 seed terms. Third is the sum of these 2, which is 1. Fourth is the sum of the previous 2, which is 2. Fifth is the sum of these 2. Yeah.
I thought that it made the first term 1, and then you would add the first and the second term to the third term.
No, there are, I think the so-called classic Fibonacci sequence starts with a 0, the first term, and the second term is 1. There are other versions of it that start with a 1. I think they give the first and the second term being 1. I guess, Chris, you have done Google search. What was the first term?
First term is 0.
Okay. Okay. So you can do a Google search to see what the. I'm pretty sure it is 0, 1, 1. That's the so-called traditional Fibonacci series. Okay. So, but the question is, what is failing now? Okay, Eric?
You didn't calculate it with the new.
Okay. This is the other part that I hope you understand. My test cannot just be for one value, right? If I want my logic, if I want to be relatively sure that my logic actually holds, I want to test it with multiple values. So I'm going to go with, well, let's see. Actually, I'll keep this breakpoint here. And then if Eric pointed out that my actual value, and this is the entire point of the discussion where I brought in Kash and Bolaji and everyone else, where is the work being done? The work is not being done here, right? So for me to get an actual Fibonacci number, where do I need to go now? Okay, calculated clause, and how will I use it? How will I have it do its work? Okay, how many of you know the answer to this? I know that Eric knows, but who else knows it? Okay.
By using calculator.
Okay, so what do I need to do? Can you tell me exactly?
You have to create, at that point, you have to create a new
I have to create a new object. What would I call it? And the object of what class? So can I just call it calculator again? So what would I have to do? Okay. Okay. How many of you suggest that I follow this design as Scott suggested? How many of you agree with this? How many of you don't agree with this? And the rest of you can go to political science or any other field. Why did I say political science? Exactly. As you can see, you can create alternate facts. Okay, so you can make up your own facts, but here you cannot. So you either have to say yes or no, right? You cannot be in between. And I will force you to do it, not because I want you to be whatever, but because that's the way you learn. So you have to take one side or the other and then be able to make a case for it, right? So those of you who said you didn't agree with Karsh's design, you have to tell me who didn't agree with this. Okay. Let's see, I'll go with, okay, Megan, why didn't you agree with this? Okay, well, what Megan is suggesting is she wants to use the same object again. Do you have any objection to that? There's no question of maybe. As I said, we are in political science. You either say yes, no. If you, what is your concern if you use the same object? Anyone? What is the potential concern if you use the same object or same variable? It's potentially going to get overwritten, right? So you have to see, does it make any, does overwriting, in this case, ultimately we are creating this object not for its own sake, but to do what? Not only test, but let's see, Ashley, what are we doing? What? We're calling the method. The object by itself doesn't do anything for us. It's not having any data. So the only reason we want to have this object is to call this method. Okay. So when we call this method, it takes whatever value input term we give it, and it does what? Finds the Fibonacci number, which it gives back, which it gives back to us. And we are going to capture it into this variable. Now is their concern. So if I did what Megan said, I wouldn't have to I wouldn't have to recreate another object. And usually, whenever you see a variable with one after it, I said, other than in very rare cases, it's a problem. So you don't want to use it. It's not good design. So I'll just say calculator dot find Fibonacci number and then input term. Okay, so what's it doing? It's bringing back a value which I give to which variable? Okay, so isn't this a concern now? Because when I do this, what happens to this Fibonacci number that came back previously with 0? It overwrites it. Isn't that a concern?
you care about these numbers in the future.
Okay, so in this case, is that a concern? Yes, no? No? Okay, why are you good with that?
If I'm testing the first one, I'll test for the first one. Oh, and it won't give a big back. The first one and the second one.
Okay, so is it a concern then?
Yeah.
It is. Okay, so who else thinks it's a concern? Who thinks it's not a concern? Okay, Logan, you're contesting the majority here. Going against majority opinion. You're willing to do that?
No,
Eric, you're still brave enough?
Yeah. So the things it's testing are the assert statements.
Okay.
So since you have two assert statements, it's going to do both of them. And the way you laid it out, it's going to run the first one with the 1 and 0 first, and then it's going to change the numbers, recalculate it, and then run it again, and it'll give you both. So it doesn't matter.
Yes, Eric just reasoned out for us. The first number, we are doing the assert to check are they equal. And then after we have checked it, we don't really care about it. It's going to say it succeeded or not, right? And then we are doing a second check with the second set of expected and actual values. So we no longer care about the previous value because that check has already been done here. Right. Okay, so it's actually good that you went through this process because that's exactly what I'm expecting you to do. Okay, but whether you went one way or the other, but if you reason through it, then you understand, right, why it can or cannot be done. In this case, it can be done. But if we needed to use it later on, the first value, then we won't be able to make a change here. But in this case, it is fine based on the logic. So now let's run this test with two different values. So let's see if it works. Okay, it says insert or equal failed, expected 5, actual 8. Okay, so what? But the expected was 5. So what's happening here?
One off again. Just doing 1 too many times.
What is it doing 1 too many times? It's going through the loop 1 too many times. Okay, so what is one simple way to prevent it from going through the loop 1 too many times? Okay, instead of it being less than or equal to, make it just less than. So it will stop one number earlier. Okay. So now if I'll just save it. Back, run all. Okay, so what does it tell you now? Okay, it's working with these two values, and now what you should do is the potential places where it can break. It can break for the first. You want to make sure that the first two seed terms are fine, right? So my first two seed terms are, so input, I'll just copy this here. Well, actually, I'll copy these 4 lines because all 4 actually go together. So I'm going to change the input term to 2. If it's 2, what do I expect here? It's going to be 1. The input term was 2, and expected was 1. Okay. Okay, so this is the 2 seed terms, somewhat higher. And then let's just go with, let's say, input 10. I'll just copy and paste this again. So if it is input term 10, what are we expecting? So 7 will be 8. 8 will be 13, 9, 21, 10. 21 plus 13, 34. Okay. You should be doing it much faster than an old mind, right? So I have to take you through mental math, I think. Anyway, so if you run this, essentially we are exercising the term that people in the software development will use the term exercising the method. So we are going to exercise the method how many times? 1, 2, 3, 4. So the more you exercise it and the more you find that it is providing valid values, correct values, the more confidence you can have that the logic is correct. But obviously right now it's coming back saying that the second seed value is failing. So it's coming back with the actual of 0. Input was 2, expected was 1. So essentially there is some problem here. So where is the problem? So when we sent in the input term of 2, we were expecting a value of 1. So instead we got a value of 0. Why did we get 0? Yellow?
Because index is 2 and then the term is 2. And it's not less than.
Okay, it was essentially, it came back with 0. So what's the solution to this? So Megan and Krista, with this logic, does it work? Yeah? Yes, Heidi? Okay. Hello. Yeah, I guess I'll stop here, and then so you can figure out how many of you had. So I know Hallie's logic works, but is there somebody else who's having it work now? Yeah. Okay, I'll hand it over to Hallie, to Heidi and
Nathan.
Nathan. Hello. I was saying that I have not heard of Nathan. Is he an MI student?
No.
Yes, computer science.
Yeah. He's from West Virginia University.
So whoever, Krista, you told me that he was MIS. So I said I don't know any Nathan, and I thought I was really getting very old. And I'll stop this now.
Do you mind if I put in a flashlight real quick?
Yeah.
I can show you.